This is Tyler, everybody.
Yeah.
Spoken at Freaknik 3 times now? 4 times?
A couple times, I don't know. Yeah, it's been a while.
Tyler Crumpton lives on creating things that don't exist otherwise, especially if they have the potential to inspire others. From playful and interactive LED displays to silly, useless IoT projects, down to synthesizers built from hot dogs. You might need to explain that.
I've got a picture.
Okay,
Yeah.
his quest is aimed at sparking a bit of joy where least expected. His toy box usually includes microcontrollers, laser cutters, 3D printers, CNC machines, and whatever else makes it easier to go from goofy idea to goofy reality. Welcome, Tyler, everybody.
Yeah, thanks, Ben. Yeah, so as Ben said, I'm Tyler. Can y'all hear me? Is this high enough? I don't know. I don't want to adjust it for everyone else, but yeah, I love making silly stuff, and one of the tools in my toolbox is CircuitPython, and so I'm going to talk about that today, and hopefully it'll inspire y'all to do some cool embedded development and make some really neat things. So the first question, what is CircuitPython? And it is a port of MicroPython. So that begs the second question, what is MicroPython? So MicroPython is a version of the Python language for microcontrollers. So it's like optimized for code space, low RAM usage. It gives you all the like APIs to like talk to pins and hardware on microcontrollers. It aims to be compatible with the normal C Python, like the desktop Python that you would run normal Python applications. There's a couple of weird things that you can't do on a microcontroller that you can do on a desktop, and things that you can do on a microcontroller that you can't do on a desktop. So there's a goal there to try to make sure that that's consistency, that you can use the same code that you would write on a microcontroller on your desktop and vice versa. And it also includes a lot of the standard libraries, so things like time and like collections and stuff like that, where you need to be able to do some manipulation on things. It gives you the same sort of like batteries included goals that like normal Python has, includes that in MicroPython as well. So now we can go back and I can answer the question about what CircuitPython is. It's a frequently updated fork of MicroPython, so they're constantly providing changes back up to MicroPython and then constantly pulling changes down from MicroPython. So they're keeping it in sync. It's not a fork that's just completely diverged and is a completely different project. They're very much connected. One of CircuitPython's goals is to make sure that development is as easy as possible. So they have a bunch of like really neat features that they've included, and a few restrictions and requirements on like what hardware is supported that makes it really easy to get started and continue developing with the CircuitPython code. And then they also include things like a safe mode that like when your program crashes, you can like go into it and like change the files so that it's not just stuck. And then it includes like an RGB LED that it uses for like status messages and stuff. So like all these requirements and extra things that they add on to it makes it just a little bit easier for people to get started with it. Some of the other things that they include are just a bunch of APIs to run the same code on computers and microcontrollers. So MicroPython makes the language very similar, very, very compatible. CircuitPython has like a compatibility shim that lets you actually run like the same code you'd run on CircuitPython on a microcontroller. You could run it on like a Raspberry Pi and access the GPIO in the same way. So you could have code that you wrote one way and just be able to use it on a different platform. And then the other big thing about CircuitPython is that they include this concept of these board definitions. So when you have a custom board, like maybe a little badge that's running an RP2040, it lets you define all of the like pins and hardware that's included on the device. So you can customize it so that when you're using that device from like the REPL, or you're writing code to it, you can say, I want to use the left button pin, instead of having to say like I want to use GPIO 27 or whatever. You don't know exactly what it's wired up to. You can just use its real name. So you're probably asking yourself, why do I care? Why am I excited? So the real cool things, and this is like where when I first like plugged it in and got it working, I was like super pumped about it. the way this works is when you plug in a CircuitPython device into a computer over USB, it just shows up as a flash drive. It has some files on it, and some of those are like Python files. And you can just edit those files with any text editor, any IDE you want. You could use Vim because it's better than Emacs, or not, whatever you want. I'm not going to get into that. I use VS Code, so I don't actually have a dog in this fight. So. But you just hit save, and it will copy that file over and live reload and start your code. So you don't have to go through a whole process of like compiling and building a firmware image and like loading it on and going through the DFU mode to copy over the files. Have y'all used like Arduino? It's like one of the like easier like embedded development processes, but you still have to like get it connected over serial, make sure it's like in a mode that can like receive firmwares, and you still have to compile and send it over. So this just makes it really easy. And if I have time left over, I'll show like exactly what that looks like. Some of the other cool things about CircuitPython is that they provide a lot of like really cool USB interfaces for HID devices, like human interface devices. So one of the really popular things that's happened is that there have been a lot of like custom macro pads and like keyboards and USB devices that people have built on top of CircuitPython and like made really cool projects to be able to like control a computer just from a couple of buttons on a microcontroller. One of the other cool things is that because it's like a USB sort of flash drive, you can actually use that for like data logging purposes. So if you have a bunch of sensors like hooked up to a microcontroller and it's like logging data and recording stuff, you can just log it to the file system as like a CSV or whatever file format, binary file format you want to log it as. And then you can plug that into your computer and like take that data off. Makes it really easy to do stuff like that. And you don't have to like build the whole like file system like architecture onto your microcontroller. And then one of the cool things that I mostly work with on CircuitPython is that it has access to like Bluetooth and Wi-Fi on certain platforms. So if you have like an ESP32 S3, you have Bluetooth and Wi-Fi available to you. And it has a bunch of like really nice APIs to make that really easy to connect to Wi-Fi, broadcast Bluetooth beacon packets, and like all that kind of stuff. So there's a bunch of supported hardware platforms. The initial ones, I believe, were the SAMD 21 and 51. So that's the first one I used CircuitPython with, way back in like CircuitPython 4, I think. They're on 8 and pushing out 9 now. There's the Nordic NRF chips that have a bunch of like really nice wireless capabilities. STM32s are really common. I think STM32s were easier to get when the chip shortage happened. I'm trying to remember exactly which ones. There was like, it was all over the place. People were switching chips and trying new things when all that was happening. My two favorite platforms though are the ESP32 and specifically the S2 and S3 chips and the RP2040. The ESP32's got the Wi-Fi, the Bluetooth, and all that stuff, and it has like really nice low power modes. And the Raspberry Pi 2040 has a really easy to implement chip, doesn't require like a lot of extra supporting hardware, and it's got these programmable IOs that like let you do these really cool sort of high speed, quick logic kind of stuff to implement protocols. So having all those platforms means that you can have a huge library of like all these different boards, and these are things that people have built. If you create a board definition like I was kind of talking about earlier that says like, it's this chip, it has this much flash, it's got these pins, and they're all called this, you can actually just open a pull request on CircuitPython from Adafruit, and they'll include it in their like CI process. They'll build firmware images whenever they release new versions of CircuitPython, and they'll post it on their website so that someone who wants to use your board can just go click on it, download the latest version, and see all the features and stuff about it. So I probably scroll past one of my boards on here. I have an old ESP32 S2 board that was on there. So some of the neat things you can do is if you have one of the Wi-Fi connected boards, so like the RP2040W or the PiPico W or any of the ESP boards, you can have internet capabilities or networking capabilities. So One of the ones I use a ton is MQTT, which is like a lightweight messaging protocol where you have an MQTT broker that receives messages and publishes them out to clients that are listening. So on the side diagram, you can see that you have maybe a bunch of sensors that are all like publishing data saying like, here's a measurement value, here's a measurement value. And then you have clients on the other side that are subscribed to whatever information they want to act on, and they'll just receive those messages. The library for CircuitPython is really easy to use. I don't expect you to be able to read this, but you can at least see the shape of the code. And it's not a lot of code. So this is not 100% a full script. There's a little bit of setup you have to do for like connecting to the Wi-Fi and stuff, but this basically is all you need to connect to an MQTT broker and publish and receive messages from it. So you can have like a callback function that gets called whenever it receives a message that you're subscribed to, or you can just call a function to publish a message on a topic. Super easy. And what that's useful for is like quick prototypes, or even like like longer term projects. But this is a project I had at work where I was trying to show off some MQTT integration with some of our software, and so I used an ESP32s and a bunch of like random sensors that you can order off of Amazon or AliExpress or Adafruit, and so it was providing like humidity, soil moisture values, temperature, some light values, and it was sending them over MQTT, and then we had our integration that was subscribed to that, pulling those values in and like showing the state of this plant pot. One of the other cool things is displayio. So this is one that I've been working on quite a bit recently. It's an abstraction over like LCD, LED, OLED, e-ink screens. And so it provides a common way to talk to these screens so that you're not having to like rebuild your sort of like graphics library just to be able to like display some text, some images, some animations on different types of LCD screens or different types of LED screens. It supports like LED matrices. It supports like color and single color, color and monochromatic displays, and like even things like the e-ink displays where you have a lot of different restrictions about like how often you can refresh the display. It kind of hides that away from you so that you can just use one sort of interface to talk to them, and it just kind of works behind the scenes. It also gives you a lot of extra tools to be able to like create interfaces. So this is using one of the like the 3-inch touchscreens that you can get that like talks SPI to a microcontroller or a Raspberry Pi, and it like kind of makes it much quicker to be able to like go from like nothing to I just want a little screen that has like some buttons, or it has a graph, or it has a progress bar or gauge or whatever. Just being able to do that so super quickly. One of the other cool things, it has a built-in terminal, which is kind of silly on the smaller screens, which is why I chose this one, because it is really cute but really silly. Whenever you first initialize a display using displayio, it will, whenever you like close your program or the program crashes, it'll actually bring up the terminal, the CircuitPython terminal, so you can actually run commands if you have it hooked up over serial and you're like typing in on the keyboard. But it'll also show you like what the error message was that crashed. So it makes it really easy to like debug your application, because if anyone's done like embedded development, sometimes like a program will crash or get into a weird state, and you have like no idea what's going on, and like as soon as you plug it into the computer, it like resets and clears all that state, and you can't like figure out what's going on, so you have to like try to like live JTAG it and all that kind of stuff. But this sometimes gets you what you need. It just says, hey, you had a syntax error on line 50. Like, that's much easier than trying to like dig into the debugger for that. And I kind of mentioned the graphical interfaces pieces, so there's a bunch of other like helper libraries that like help you like display text, do animations, build custom fonts, and then there's like some third-party libraries that people have built on top of displayio that lets you expand that even further. Like they have like little menus that you can use to select, so you can actually build libraries that are broadly available to anyone with any kind of display, as long as you build it on top of this API. One of the other things I wanted to talk about, is because I've been messing with it a bunch recently, is the low power modes of different microcontrollers and how CircuitPython interacts with that. So if you have a low power device, you want something to run off of batteries, and you just have the code just sit there and do nothing, even in just like normal operation, it's drawing like, in this case, I think this is the ESP32s, it's drawing like 50 milliamps, just flat level, not even connected to Wi-Fi. And so if you have a 500 milliamp hour battery, that's going to last you, 10 hours, right? Did I do that math right? 510, yeah. Not very long if you want something to run for like a month out, like out in your garden, sending values back or something. The low power modes can help put things to sleep so that whenever you're like not doing anything, you're just saving power, it wakes up, takes a measurement, sends something, does some processing, goes back to sleep. CircuitPython has a couple of different power modes that you can use. There's light sleep and deep sleep. Light sleep is a mode that will kind of put the chip into like an idle mode. It doesn't save like a ton of power, but whenever you go into light sleep and wake up from that, it will just continue where it was. So it's like really easy to sort of just like stop processing anything and wait for something to happen and then just continue on. Deep sleep will actually shut down most of the pieces of the microcontroller, a bunch of the different peripherals, it'll make sure all the radios are powered off and all that kind of stuff. But when it wakes up from deep sleep, it usually restarts the chip. So there's a couple of like little tricks you have to do to like maintain state across those reboots. And then on top of that, there's 3 different types of alarms to wake it back up. You have time alarms, which say like, I want you to wake up in 10 minutes. So like take a measurement, go to sleep, wake up 10 minutes, take a measurement, send it off, go back to sleep. There are pin alarms, which will detect like a rising or falling edge trigger on a pin. So if you have a button that you want to use to wake it up, or you have some other device that you want to use to wake it up. On my like little badge, I have like a little shake sensor that wakes it up whenever it makes a bridge across the contacts there. And then some platforms also have touch alarms. So you can have capacitive touch pads on a board that you've built, or just like little bits of wire sticking out. Like doesn't matter, as long as when you touch it, the capacitance changes. You can use that to trigger it to wake up. The ESP32 has a bunch of these sort of touchpad peripherals. The RP2040, the Raspberry Pi, does not, unfortunately. And the different alarm types require different levels of like power. So definitely recommend like kind of playing around with it if you want to find out like what's going to be best for your project. But there are some good like pieces online that people have done a lot of like measurements and recordings on like the different modes with different peripherals turned on and off to see how much power it draws. But it's all going to depend on your board. If you have a voltage regulator on your board, so it's all going to change that kind of stuff. I mentioned that if you use deep sleep, it usually restarts and starts your program all over again. This is one of the ways to kind of carry state across restarts. You can use sleep memory, which is like a really low power RAM that you can store data into, and then whenever it restarts and wakes up from sleep, it will have that data retained, and then you can use that data to sort of go to the next step. So like if you want from like a cold boot, you want your device to wake up, read some configuration data, maybe stay awake for a couple of seconds so that you can like press some buttons on the menu or something, and then go to sleep, and every 10 minutes just wake up, take a measurement real quick, send it out as fast as possible, and then fall back asleep. You can use this to kind of like define those states that you want to do. And it's really easy. It's just bytes of data. So there's the alarm.sleep memory array list of data, and you can just access those elements right to it and read from it. So this tiny little script right here basically is an example where it's like, yeah, you want to take a measurement, increment a counter, and then go back to sleep. And on the 10th measurement, you want to send it out like over Wi-Fi, because like sometimes connecting to Wi-Fi takes a couple seconds. So like you might batch up 10 measurements over 10 minutes and then send out that whole chunk at once. And it makes it really easy to do that. All right, I don't have a ton of time left, so I won't dig into those, but I do want to call out a couple other really cool libraries. Synthio is a synthesizer library for generating audio synthesis, so generating sound waves, envelope functions, LFOs, all sorts of kind of stuff like that. Really fun, kind of new. Definitely recommend checking it out if you like synthesizers. Fancy LED or Fancy LED. It's sort of a it was inspired by Fast LED, which is a really nice like animation library for individually adjustable LED strips, and this provides a very similar interface into CircuitPython for that. So that's really cool. It actually has some helper functions to help you convert Fast LED code into fancy LED code. MIDI. So we mentioned hot dog synthesizers. It does provide a really easy to use MIDI USB API. And so that was one of the things I built during the pandemic because I was bored and out of my mind. I built a touch-sensitive hot dog MIDI synthesizer. So as you touched the different hot dogs, it would send different MIDI messages to the computer. I've got a video of it somewhere I'll have to show, but it was very uncomfortable, but very fun. But being able just to use the touch pins and the MIDI stuff, I think it was like 60 lines of code to build that whole thing. It was like nothing. Adafruit requests, which is like another compatible library that's supposed to mimic the Python request library. So if you want to talk to an HTTP endpoint and send data or receive data, or go like look up the latest news feed or the temperature from like a weather app, something like that, you can use that. And then one I haven't actually used yet, but I want to get back into this a little bit more is Tiny LoRa, which is the long-range radio, low bandwidth, high distance sort of radio protocol that uses these like tiny little like chirp messages to like send really small packets of data and receive small packets of data. They have a really nice API around this, and that makes it a lot easier to like handle talking to these like weird radio transceivers and like formatting the packets just in the right way to get them sent across on the line. So with that, I want to put up this really cheesy thing that I wrote last night, like 1 a.m. That Arduino is kind of like the thing that like really kickstarted the embedded programming is for everyone sort of movement, and I think CircuitPython like takes that and like cranks it up to 11. Just being able to like plug in a device and edit the code and watch things happen is so much easier and so much more like accessible to people than having to like download the Arduino IDE, make sure that you have all the right like board things set up, compiling C code. Like that's a lot you have to do, and you have to like get past just to make changes. I have like one story where I built a custom keyboard for a friend, and it just was like a couple of buttons, and it had a bunch of little Easter eggs if you hit certain key combinations and stuff. And I gave it to them, and I was like, here, I made you this keyboard. I use CircuitPython internally because I wanted to be able to like use the HID devices to be able to like type messages on the keyboard. And they had never like touched Python or anything like that. And they plugged it in. They're like, I noticed it showed up as a flash drive, and there was a Python file, and I just opened it up and I changed some things. They're like, look, I made it blink whenever you type E. And I was like, this is so cool. Like, I didn't even tell you what this was, and you just like discovered it. Like, you accidentally did embedded programming. Like, that's how easy it is. Like, but yeah, so I've been really excited about that because like that makes it really available to people, and like people have been building custom keyboards and widgets and devices, and I don't know. As someone who likes to watch people get excited about like building things, that's really awesome to me. So I just wanted to call that out. We've got a couple minutes, I think, but yeah.
Does the firmware have a file watcher, so when you update a Python file, is it automatically reloaded? You still have to like power cycle or?
Yeah, it has a file watcher. So like as soon as you hit save, it automatically like restarts. You can disable that if you don't want that to happen. If you're like, I'm just making some changes and I want to like manually reset, you can. But yeah, the file watcher on the device just like looks for changes to files and will just restart it. So like if you add a new library file or change your code file, it'll just restart and run. Anyone else? Yeah. Or, yeah. You go ahead. Yeah.
Are good like PWM functions?
Yeah. So it's got all the like sort of standard like I/O functionality. So you have like PWM, you have pulse counting, you've got like ADC values, digital I/O, like in and out with pull-ups on and off and all that kind of stuff. It also has like all your standard like wiring protocols like I2C and SPI and one wire and all that stuff as well. So it gives you a lot of that stuff out of the box, and then there's libraries that add on to that as well.
I was going to ask, are there any like libraries to make it easy to integrate with Home Assistant?
Yeah, so the MQTT is probably like the easiest way to like get a CircuitPython device connected to Home Assistant. You can also use the request library to do like HTTP commands. Home Assistant, I think, lets you have like a webhook endpoint that you can like call and commit events that way. But yeah, MQTT is like the most straightforward. It's just connect to the Home Assistant MQTT broker, send a message on a certain topic in a certain format, and it'll just like be included in the system. So. All right. Well, thanks, y'all. I'm going to be around the whole con, so if you have any more questions or anything like that, just come find me. Yeah.
Did you eat the hot dogs and did they taste different?
I wanted to. I couldn't though. After touching them, they got like dried out and like weird, and I was like, I can't do this. I will eat a lot of garbage food, but I'm gonna let these ones sit because I also had another pack of hot dogs in the fridge, so like
They're hot dogs.
yeah, they're like so. Also, I have this badge I've been developing. I don't know if I'll finish enough of the software while we're here, but I'm going to try to work on that. And so if you want to play around with CircuitPython, I'll have some of these badges. I've got like 15 right now that people can play with, or if they want to buy one. But it's running the RP2040 Raspberry Pi chip, and so you just plug it in, and you can start messing around with the code. You can see all my awful code that I've written in the last.
How much are they to buy?
$25. So there's a couple like hardware glitches I want to fix out and for the next version. But yeah.
You mentioned VS Code. Do you use like Platform IO, or is it way simpler?
For me, it's a lot simpler. There is a VS Code integration for CircuitPython that makes a couple of things really easy, like auto installing libraries, kind of like how Platform IO works. But you don't have to have that, just because you can just open that thumb drive as a file in VS Code and just hit save. But I also have a couple of things that like make it a little bit easier for me on VS Code, where I edit code locally and it copies the file over whenever I hit save, so that if I unplug my CircuitPython device and put it in a box and I want to look at that code later, I'm like, oh yeah, I forgot I wrote it on the device itself and I don't actually have that source anymore. So I have like a little extension that just kind of like copies it over for me. But you don't have to have any of that. But the CircuitPython extension kind of gives you some nice to have things like auto-completing for the built-in CircuitPython libraries and stuff like that. Yeah?
Sorry for the question.
No, it's good.
All like shared libraries, is there really like a pip install that you can do?
Yeah, so yeah, Adafruit has a tool called CircuitPython that is basically sort of like a pip install kind of tool. You can also just download the library bundle and just drag and drop them into the libraries folder on the flash drive. And that's basically what CircuitPython is doing. It's just copying those files over and making sure they're up to date. But yeah, it's like super easy to install libraries. There's an official bundle that's published by Adafruit, and then there's also a community bundle that they sort of maintain and build all the like Python files for. But you can download and pull extra libraries out of that. Or if you find something online, you just grab that folder, drag it in there, and it'll be available for you. Cool. Well, I don't want to take up any more time. If y'all have any more questions, just come find me. I'll be around. And thank you all.